David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Today's topic, problem solving with trigonometry. So yes, if you thought word problems, you're right. Now, trigonometry is one of those topics that really lends itself to real-life types of word problems. Ever look up at the top of a building and wonder how high off the ground it was? And then realize that, well, I don't even have a ladder that gets up there. I don't know how I could possibly measure that. Well, guess what? You could use trigonometry to calculate that height without ever leaving the ground. Okay, so let's get started. First, a little bit of definition terminology stuff. We have these two terms, angle of elevation and angle of depression. And you've got to understand what those mean because those will be setups for some of the problems. So take a look at this first one. I've got a tall building here, and I've got a person standing there looking up at the top of the building. So the angle that their line of sight makes with the ground as they look up, we're going to call that theta in this case. That angle is called the angle of elevation. And elevation means upwards. So think about angle of elevation as looking up from the ground to the top of something. That's what we put there. Now the reverse of that is you might be at the top of a tall cliff looking down to some point on the ground ahead of you. So that would be looking down from the horizontal, and that's an angle of depression. And think about depression. It's feeling down, looking down. So in this case, I use the Greek letter beta to indicate the angle of depression, which is looking down. Okay? Now, I want you to think for a minute. These two angles are related in a pretty special way. I'm going to put up another board in just a sec, but I want you to pause the video, think about how they might be related. Okay, hopefully you came up with an idea. Take a look at this diagram, see if that changes your idea. Okay, let's take a peek. So I got the building situation here again, and a person looking down to this point on the ground, they have this theta, angle of depression. The person on the ground at that same point looking up to the top has this angle of elevation, and I use the same letter. And if you thought angle of elevation is the same as angle of depression, you're right. Now think, why is this the case? Tell me why these two angles are the same. Okay, here's the thing. This has to do with parallel lines. This is a horizontal. So is the ground. Okay? So a horizontal line is going to be parallel with the ground. This line of sight, either looking up or looking down, is a transversal that's cutting these two parallel lines. And so we know from parallel lines that alternate interior angles are equal. So this angle has to be equal to that angle. So just remember, angle of elevation is the same as angle of depression. You might have a problem to do where they give you this angle, but you need to understand that that also gives you this angle before you could calculate the height of the building. Okay, let's do a problem. Now, right away you're going to notice there's no diagram here. I haven't given you a picture. So sometimes the first and most difficult step with one of these problems is to create that diagram. So let's take a look at this one. The angle of elevation from you to the top of a cliff is 37 degrees. If you are 26 meters from the cliff's base, how tall is the cliff? So let's draw a picture. Here's my cliff. Here's the ground. Okay, so now I have my picture. Now, I am 26 meters away, so I'm somewhere like over here at that point. And now I can label this. This distance is 26 meters, like that. Now, we're talking about the angle of elevation from me to the top of the cliff. So I'm looking up to the top of the cliff, that'll do. And here's my angle of elevation, and I know that it's 37 degrees. Okay? So now I have my diagram with one exception. This is trigonometry. So far, there's one more thing we need to mark on this diagram that gives us permission to analyze it with trigonometry. What is that? If you thought we need a right angle, you're right. And here is my right angle. It is reasonable to assume that my cliff is vertical with respect to the ground, and that would have 90 degrees right there. If you can't find a 90-degree angle in your picture, then you can't use SOHCAHTOA geometry, which is what we're going to do here. Okay, so I have a nice diagram. I've labeled it. I put all my numbers on it. Now it's time to mark my unknown. So what am I being asked to find? How tall. So I'm going to mark an X right there. This is the height of the cliff. So now you just stare at this picture and figure out which trig function you use. So, ca, or toa. So let's do that. I'm standing in this angle down here, and I'm looking out at my triangle. This side is adjacent to me because it's touching me in this angle. So I have the adjacent, and I want to know the opposite. Remember, this is the hypotenuse because it's across from the 90-degree angle. So which trig function deals with adjacent and opposite? And if you thought tangent, you're right. That's the TOA of SOHCAHTOA. And that means tangent equals opposite over adjacent. So now this could do a plug-in step. Tan 37 equals opposite x over adjacent 26. And then you know from our little rhyme, when the variable's up high, you multiply. So x is going to equal 26 times tan 37. Now you can't solve this without a calculator. So pull out your trusty calculator, put it in there. 26 times 37 tangent equals 19.6. So this cliff is 19.6 meters high. So let's do another problem. Again, we're going to start with words only. Go to the diagram, go to the equation, solve the equation, get our answer. So you've got a 20-foot ladder and it leans against a tall wall. So some maintenance person has leaned that ladder up against the wall. They're going to climb up to the top to do some maintenance, fix a window, something like that. Now, if the top of the ladder touches the wall 17.5 feet above the ground, find the angle that the ladder makes with the ground. So you know right away here that we're going to use inverse trigonometry because we need to find an angle this time, not a length. All right, so pause the video right now and see if you can sketch in a diagram of this situation. Okay, let's see how you did. Here's my wall. There's my ground. Here's my ladder. You know, the steps on the ladder. Dun, 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 dun. The ladder is 20 feet, so this distance is 20, and it touches the wall 17.5 feet above the ground. So 17.5 feet. Right there. Now what are we being asked to find? Find the angle that the ladder makes with the ground. So that would be right here. That's our theta that we need to find. Okay? Now you could say, well, what about that angle? And truth be told, that's a valid angle, of course, but it's not inside our triangle. So this is the one we want. Now what you want to do, pause the video and see if you can write an inverse trig equation to solve for theta. Okay, so if you're in here, if you're sitting here in the angle, you know the opposite and you know the hypotenuse. So the trig function that deals with the opposite and hypotenuse is sine. That was the so, right? Sine is opposite over hypotenuse. So now we're going to write sine theta equals opposite 17.5 over hypotenuse over 20. Now that's going to give us an inverse equation of as follows. Sine inverse of 17.5 over 20 equals theta. So now I just have to put that in my calculator. Oops, there's a little -1 there. Sine inverse of 17.5 over 20. So now my calculator, what I do is I do 17.5 divided by 20, figure out what that is, and then do the inverse sine of that, and I get 61 degrees. So that angle is 61 degrees. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.